Alrighty, so we are going to continue with solving systems of equations. Yesterday we did the graphing method, which provided us with a solution of a coordinate point, x and y. Okay, today when we use substitution to solve this system of equations, we will still come up with the exact same coordinate point, however we will do it algebraically instead of graphing, okay? So I gave you the steps here. It says to solve one of the equations for one of its variables first. So we want either an x equals or a y equals is essentially what we're needing there. That way we can substitute it in. So x equals or y equals. Now, if I'm telling you to solve by substitution, you will have to make that happen if it's not already in a form like that. If I tell you to use any method that you would like, I would only use substitution if it's already in y equals format or x equals format for one of your equations, okay? But for now, if it's not like that, you will have to set it up so it's going to be in an x equals format or a y equals format, so we can use the other half of that equation to substitute in, okay? Then, if you read through, you're going to substitute the expression from step 1 into the other equation, because you're going to have two equations. The value that you get when you substitute in step 2, you're going to use that to substitute back into the very first equation to get the other value. Now, that sounds kind of funny, but let's go ahead and do an example so you see what I'm saying here, okay? So for the first one, we have 4x plus 3y equals -2 and x plus 5y equals -9. So since I'm telling you to solve the system by the substitution method, you need to make sure that one of the equations is in x equals form or y equals form. So neither one of them are, but I'd like to take the second equation and make it into an x equals format. So I'm going to subtract 5y on both sides. And so this equation is now going to be rewritten as x equals -9 minus 5y. Okay, so x is equal to an expression, all right? So since I have this equation as this, I'm going to go ahead and take what x is equal to, which is this piece, and I'm going to put it in for x in the other equation. Okay, the equation I did not set up with x equals. So for, instead of x, I know what x is, it's -9 minus 5y. And then I'm going to continue with the rest of the equation. So I plugged in x. Now I still have plus 3y in that equation, and I still have equals -2. So at this point, I'm going to go ahead and distribute and combine like terms, which is actually what Algebra 1 is doing right now. So we're going to distribute. We have -36 minus 20y. And I still have the plus 3y here, and I still have equals -2. Okay? So at this point, since I only have one variable now, I'll be able to find what my y coordinate is. Okay? So I'm going to go ahead and combine -36 with nothing. I'm also going to combine -20y and positive 3y, which leaves me with 17 negative y's, which equals -2. What we're left with is a two-step equation. So since I'm isolating y, so I can find my y coordinate, I'm going to add 36 to both sides of my equation. So I have -17y left on this side of the equal sign. I have 34 left on this side of the equal sign. Isolate y to find out what y's value is, and I get y equals -2. So my goal here is to find a coordinate. So what I'm going to go ahead and do is down at the bottom, I'm going to put, okay, I know y is -2, now I just need to find x, all right? Well, now that I know y, I'm going to plug it into that x equals equation, because x, remember, equals -9 minus 5y. But I know the value of y now. So let's plug that value of y in so I know what x is. Negative 9 minus 5, and instead of y, I'm going to put negative 2. So when I evaluate that, negative 9 plus 10, because we're using PEMDAS, we have to multiply before we combine anything, I get x equals 1. So my solution to this system of equations is 1, comma, negative 2. Okay, so let's move on to number 6 so we can try that one out. Again, since we're using the substitution method, we need to make sure that we have an isolated variable, either x or y. Well, in this case on number 6, we don't have either one of those equations already set up in that format. So we're going to go ahead and use whichever one's easiest. And in my opinion, I think this one would be easier to recreate in that format. Okay, so right now I have 2x plus y equals negative 1, and it's real simple to isolate y. So I'm going to subtract 2x on both sides of the equal sign, and my equation for this is now y equals negative 1 minus 2x. Okay, so I don't have this anymore. I have this equation that I'm going to be using. All right, so once that one's isolated, then I'm going to go ahead and plug in what y is congruent to or equal to or equivalent to into my other equation that's not set up in that format. So I have negative 4x here plus 6y. Well, I know what y is. Y is negative 1 minus 2x. Okay, and then I still have equals 6 in that equation. So at this point, we're going to go ahead and use our distributive property and then combine like terms. So I still have this negative 4x plus 6 times negative 1 is negative 6. 6 times negative 2x is negative 12x. And we still have equals 6 at the end. All right, well, let's simplify here. Negative 4x and negative 12x, I have 16 negative x's now. Minus 6 equals 6. Okay. So solving for x, I'm going to go ahead and add 6 on both sides. And I'm left with negative 16x equals 12. I'll divide out the negative 16 on both sides. And x equals negative 12 over 16, simplified as, if we take out a common factor of 4, simplified as negative 3/4. So that's our x value. Again, we're looking for the solution, and the solution to a system has to be a coordinate point. So we have negative 3/4 as my x. I'm going to leave a blank for my y because I don't know what that is. But since I know what x is, I'm going to plug it into that y equals equation we made earlier, and then we can find out what y is. So y, recall, is negative 1 minus 2x. Well, now that I know x, I can plug it in. Y equals negative 1 minus 2 times negative 3/4. Don't freak out. It's okay. It's just a fraction. That just means we're going to make the 2 into a fraction also. So I have y equals negative 1 minus 2 times negative 3, which is a negative 6. So minus negative 6 over 1 times 4, just like so. Remember, a minus and a negative just means that they're going to add. So we're going to change it to a plus. 6 over 4 actually reduces to 3/2. Okay. Negative 1. Now I can't add negative 1 the way it is. What I am going to have to do is make it have a common denominator with my other fraction. So if I want it to have a common denominator of 2, that means I have to multiply its denominator by 2 and its numerator by 2. So I have negative 2 over 2 plus 3 over 2. Denominator stays 2. And negative 2 plus 3 in the numerator has a sum of 1. So y is 1/2. So my final coordinate point is -3/4, comma, 1/2. Now, those first two problems that we did were the common mainstream problems, and you'll typically get an x and a y. Now, there are times, like on number 7 and 8, where that doesn't occur. So we want to make sure we talk about that because remember, you're not always going to get one solution. You could get an infinite number of solutions. You could get no solution, okay? So we want to make sure we see what that looks like algebraically. So let's go ahead and start by making sure that one of our equations has an isolated variable. So on number 7, I'm going to recreate this bottom one. So I'm going to add 4x on both sides. So I have 0x's left on the left side. So I have y equals 3 plus 4x. Okay, so I'm not going to use this equation anymore. This is going to be my second equation. Y equals 3 plus 4x. All right, so increase the size of it a little bit so we can see what we're doing here. Now, with that equivalent expression, so y is the same as 3 plus 4x. I'm going to put this 3 plus 4x in the y spot in the other equation, okay? So I'm going to have 12x minus 3, but instead of y, I'm going to put 3 plus 4x equals -9. Let's start distributing. Let's start combining like terms. So 12x minus 9 minus 12x equals -9. If you have some mathematical background, you might start seeing something that looks kind of like, oh no, what's going to happen here? That's what I'm looking at. I'm like, oh no, I'm seeing that 12x is going to cancel out this -12x. We're going to have 0x's left over. And I'm going to be left with -9 equals -9. Well, that's weird, but that's a true statement. So since this is a true statement, then that means that there are an infinite number of solutions in this case. So if you end up with no variables left over for you to be able to find an x value and a y value, then you need to check whatever statement is left and see if it's true. If it's true, it's an infinite number of solutions. We can't just pinpoint one. If it's not true, then what you'll see is in number 8 is that there are no solutions. So let's take a look at that one real quick. Okay, so again, please make sure that you have one variable isolated. I'm going to use this equation and rewrite it on the top. So this one I'm going to rewrite as x equals -8 minus 5y. I just moved the 5y over, subtracted it from both sides. Okay, so let's go ahead and plug in the equivalent expression for x in the second equation. So 3, and in parentheses, -8 minus 5y, because I'm replacing this x with the equivalent expression, plus 15y equals 10. All right, let's start distributing and combining. I'm going to distribute to both terms, so I have -24 minus 15y plus 15y equals 10. Whew. All right, same thing's happening here. We have our variables canceling out. These combine and make 0. So I'm only left with -24 equals 10. Notice those are not equal. So that means this is a false statement, and if it's a false statement, then there are no solutions. Okay? There are no solutions for this one. That must mean that they're parallel. Okay, now I want to make sure that we put this into a real life situation. And so here's where we're at here. We have you and your sister, and you're going to combine your weekly overtime earnings to buy a birthday gift for your mom. Your overtime rate is $18 an hour, and your sister's is $24 an hour. Okay? So for every hour you work, you get 18. For every hour she works, she gets 24. And together y'all made $288. So let's call you X. So $18 times X number of hours that you worked plus 24 times Y number of hours that she worked. And together y'all got $288. All right, so let's keep reading. So y'all each work different hours, probably. Okay, let's keep reading and find out. If you, which you're X, you work 2 more hours than your sister, how many overtime hours did each of you work? Okay, so you are X. You work however many she worked, which is Y, but you add an additional 2 hours more than what she worked. Okay, so we have 2 equations. If we find X, that's going to tell us how many overtime hours you worked. If we find Y, that'll tell you how many overtime hours your sister worked. Okay, and then we'll just double check ourselves. All right, conveniently, we have a variable that is isolated already. Okay, so we have X equals Y plus 2. Well, let's then go ahead and put this Y plus 2 in for this X. So 18, and replace X with Y plus 2, plus 24Y equals 288. Okay, so let's distribute and combine like terms. 18Y plus 36 plus 24Y equals 288. All right, seeing some Y's here that can be combined. So when I add those, I'll get 42Y plus 36 equals 288. So we can still get an X and Y coordinate, but it has some context to it now because Y represents the amount of hours your sister worked, X represents the number of hours you worked. Okay, so if we continue to solve, 42Y is equal to 252. And if we divide by 42, we get Y equals 6. So you can maybe even do this last part by not even going back to the equation because you recall that you worked 2 more hours than her. So I will go ahead and write that down, but you are X. You worked the same number of hours as your sister, but another 2. So X is 6 plus 2. So your final answer is 8 for X, 6 for your sister. So your X value represent your hours, and the 6 in the Y position represents your sister's hours. Ta-da!